My name is Pavel Zhukov. I'm distribution engineer here at SUSE. Today we are going to see how Linux and real-time operating system can be used together to advance safety in automotive sector. To achieve this, we will need our team. We'll see what the current project we're working on is. It's called Car Wash. Then we will switch to Linux and safety topic, and we'll see. Of course, we'll see some demonstration. First of all, our team is a team of software and test engineers. We have release engineer on board as well, and of course our team leader. And our goal is to create a products, associated products which can be used in automotive sector. One of them is Car Wash, which is quality managed automotive Linux. The Linux distribution which can be used in automotive sector, and it is used, as we will see later. It's based on Linux, SUSE Linux Enterprise Server, well-known, proven in use Linux code stream. It's tailored to fit the automotive use cases. For example, it runs real-time Linux kernel instead of standard one, with more than 50,000 parameters adjusted. It contains only minimal set of packages to reduce the dependencies and to not include GPL-free license, which is problematic because of TOization. Besides of this minimal set of packages, which runs on production cars, on car itself, Car Wash contains development overlay, which includes additional packages for development, for debugging, and testing. This product can be maintained up to 10 years, depending on the customer's need, and the update and maintenance process is proven, well documented, and very stable. It's in production since 2021, so in 2 years, for 2 years by now, and it runs on a x86 architecture and supported on ARM as well. However, this is quality managed automotive Linux, and the problem is it's not safety certified. And it's not safety certified because Linux and safety applications certification is tricky due to its complexity. Linux is very complex due to lack of determinism, due to the pace of development of the kernel and some products inside of the distribution. For example, Linux kernel management list contains hundreds of patches every day, so it's changed very fast. And of course, limited control over hardware and drivers, because not all hardware provided by Linux community itself. Actually, it's provided by hardware vendors, and they provide usually the drivers. Not all drivers included in the kernel, in the upstream kernel. Some of them are third-party drivers, so the control here is really limited. An alternative can be real-time operating systems such as Zephyr, FreeRTOS, and others. They can be certified, but they don't have too much applications because they're not so popular platform as Linux is. The development costs to develop on this product new applications is higher than the one on Linux. They don't have any API. They're not POSIX compatible in most cases. They're not portable, and they're very complex. For portability, we can say that some of them have some sort of exception. For example, Zephyr can run on a wide range of architectures, but still it's less than Linux, and other points are still there. One of the solutions we are going to follow It's using quality managed Linux, which already have, and hypervisor, which SUSE already has. That's we contribute to Zen, and we have few key Zen contributors on board, and add some real-time operating system for safety monitoring, which allows us to use the Linux applications, which allows us to provide customers with hypervisors, separation, and communication between this Linux and next part, which is real-time operating system, which can be used as a safety monitor uh, this installation. And here we can see an example which will be used in the demo. First part of it, it's Linux distribution. It's based on next generation of SUSE Linux, which is called ALP, and its flavor automotive. The name is still temporary and can be changed, but that's a working name for now. And hypervisor, as I mentioned, it would be Zen. However, it can be replaced with any other type 1 hypervisor. And real-time operating system, a monitor for safety, and in this demo, it's going to be Zephyr. So, as you can see from this part of the screenshot, Zephyr monitors Linux application. If Linux application misbehaves, the monitor will intervene to prevent any critical issues. Basically, it depends how it's set up. It can just warn operator or user, or can kill the problematic domain, or do nothing, or restart services, or anything which can be configured or developed. So here's the diagram how it's done. Current demo implementation still contains DOM0 in Zen terminology, which is domain which manage other domains and provide them with drivers such as paravirtualized block devices, network devices, and so on. However, in this setup, DOM0 doesn't start domains by itself. That's so-called DOM0-less configuration, where domains are started by the Zen kernel itself using, and the configuration is stored in U-boot configuration file, and then Zen reads from it and starts the guests. All guests except DOM0 in that case communicates via shared memory region, which is shared between all domains. So basically in the demo we will see two Linux domains update this shared memory region with simple increment of how watchdog works. And once Zephyr see that this increment is not incremented by one, or stopped, or somehow misbehaved, it will kill the domain which misbehaves. So let's see how it works. Here we have Raspberry Pi 4 machine. It's already booted to save some time, because boot time of this configuration may take a while. So we can see here is the first domain and few machines running. So domain 0, as I showed in the demonstration, that's like management domain, which manage only block devices in our case. DOM0-1, this is our real-time operating system domain. It contains only 60 megabytes of memory. It can run on less memory amount, but for convenient configuration, I just use this pretty big amount of memory for this purpose. And two domains, which are basically Linux, they run as usual. Linux is under them. So if we switch to domain 1, there is no serial input, no serial output. Okay, there is serial output, we'll see later on. So domain 2, we can see it's automotive Linux. It's running real-time kernel, and we can check if it's actually has a shared memory region and corresponding device which is responsible for accessing the memory. It can be used for access the memory. So this simple C application which emulates the workload and update shared memory, as I mentioned, to emulate a real life scenario. So if we will start this application, you can see that then that application is started. It's running on domain 2. And then we see that domain 1, which is actually our real-time operating system domain, recognizes that domain 2 becomes alive. And after 20 seconds, it starts to misbehave because it's currently hard-coded in the Linux application code of the Hypercar app I started before. And now if we press enter, we see that domain's already killed. So it managed to update memory twice actually. So it updates first time, and then during this small amount of time in which dock kicked in, it managed to update it twice. So to see that other machines still running, we can still log into the second Linux domain. I mistyped the password. We can log into the second Linux domain. It's still running perfectly fine, and we can actually start the application here. Switch to domain 0 to check what the current status. So domain 2 is dead because it was killed. And domain 3 is still running, and after 20 seconds it should be killed again. So we again see that it start to doing some wrong things. Real-time operating system detected this, and the domain is killed. So now we are safe again. The unsafe system isolated. Basically, it's killed in this case and should be restarted. This demo shows us how this can be used together. This is still early demo stage, so it doesn't use some features that then provides to make it even more usable and more featureful, let's say. But at this point, it already can do its job. Thank you for attending the session. I hope it was helpful. If you have any questions, you can contact me or any other SUSE person out of them.